Question 14, Part A. Find the domain and range of the function that is the solution to the differential equation dy dx equals e to the power of x plus y and whose graph passes through the origin. The differential equation can be expressed as dy dx equals e to the power of x times e to the power of y. If we reverse this, if we're multiplying two terms with the same base, we add the indices. So e to the power of x times e to the power of y is e to the power of x plus y. So the reversal of this is this. Now applying separation of variables, we have dy over e to the power of y is equal to e to the power of x dx. Now dy over e to the power of y can be expressed using negative indices. So we have e to the power of negative y dy is equal to e to the power of x dx. Integrating both sides of this equation, we have the integral of e to the power of negative y dy is equal to the integral of e to the power of x dx. And performing the integration, taking note of the negative index here, we have negative e to the power of negative y on the left-hand side equals e to the power of x plus the constant of integration c, which we need to find. Now it's given that the graph, or the solution, passes through the origin. In other words, when x equals 0, y equals 0. So substituting x equals 0 and y equals 0, here and here, we have negative e to the power of negative 0 is equal to e to the power of 0 plus c. And negative e to the power of negative 0, of course, is negative 1, is equal to 1 plus c, which gives us a value of c of negative 2. Hence, the solution to the differential equation dy dx equals e to the power of x plus y is negative e to the power of negative y equals e to the power of x minus 2. But we want to make y the subject. Firstly, multiply both sides of the equation by negative 1 to eliminate this negative here. We have e to the power of negative y equals 2 minus e to the power of x. Taking the natural logarithm of both sides, we have ln of e to the power of negative y equals ln of 2 minus e to the power of x. And ln of e to the power of negative y is negative y, and that's equal to ln of 2 minus e to the power of x. And multiplying both sides of the equation by negative 1 to isolate y, we get y equals negative ln of 2 minus e to the power of x. Consider the domain of the function y equals negative ln of 2 minus e to the power of x. Now an ln function expects a value that's greater than 0. That means 2 minus e to the power of x has to be greater than 0. Rearranging this inequality to isolate e to the power of x, we get e to the power of x is less than 2, and taking the natural logarithm of both sides, we get x is less than ln of 2. Let's consider the range. And let's see what happens as x approaches negative infinity. Now, if we go back to our function here, e to the power of negative infinity will approaches 0, which means that y approaches negative ln of 2. And I've stated that here. As x approaches negative infinity, y approaches negative ln of 2 since e to the power of x approaches 0. Let's see what happens as x approaches ln of 2. If we go back to our function here, e to the power of x approaches 2, which means ln of 2 minus e to the power of x approaches negative infinity, but it's negative ln of 2 minus e to the power of x. This is a positive. And a negative of a negative, of course, turns this negative infinity into a positive infinity. Hence, y approaches infinity, also given dy dx is greater than 0. That means the gradient of the tangent at any point is positive. That also means that the graph is monotonic increasing. So if this is the low point of the graph, in other words, y approaches negative ln of 2 at its low point, from this point, the graph goes up to infinity. Again, because the gradient is positive all the way through. So putting that all together, the domain of the function is negative infinity comma ln of 2 in interval notation, noting the round brackets, so it doesn't include the endpoints. And the same thing goes for the range. We're using round brackets because the endpoints are not included. And the range is negative ln of 2 comma infinity.